So this is Calculus 7.3, and we're just going to do 3 examples because that's all we got to today. And this is the first one. So of course what you have to do first is graph it. And we're graphing y equals x cubed about the y-axis. So this is going to rotate over here. And we're going from y equals 0 to 8, so I'm not even going to bother with the bottom part here. And we get this sort of this bowl-shaped thing. And we're going to try to find the volume of that. So in order to do that, we need to use, the cross-sectional slices. You want to think about your cross-sectional slice here. So that would be like so. And then the thickness is dy. It's important to figure out your cross-sectional slice so that you know your thickness, if it's dx or dy, because then now I know that I'm going to be setting this up in terms of y, not in terms of x. So we'll go back to the disk method, because this cross-sectional slice is a solid disk. And if you think back to this previous slide, that would be the integral of pi r squared dx from a to b. Except for it's not going to be x, it's actually going to be in terms of y. So we'll have the integral from a to b. Now in this case, because our thickness is dy, my limits, integration limits, are going to be in terms of y. So my slices are going from 0 to 8. And then it's pi times the radius squared. And the radius is from the center, the axis of rotation, out to the edge, which is the function. However, it's not going to be x cubed here because we want it in terms of y. So instead, we'll take this function and we'll solve for x, so we'll get the cube root of y. So the cube root of y will go here. But we're not done yet, because remember, it's actually pi r squared, so this whole thing is r, and we have to square it. So make sure you remember to do that. Now it is set up correctly, and you can integrate it. You can try that on your own. I'll just do it real quickly here. So that's y to the 2/3 dy. And then to integrate, we can use the power rule, so we can add 1, which is going to be 5/3 times 3/5. There's the pi there from 0 to 8. So we're going to have 3/5 pi. That's 8 to the 1/3 to the 5th. So that's 2 to the 5th, which is 32. 32 times 3 is 96. So 96/5 pi, which should be 60.3198. Here, let's try it, make sure. 96 second pi divided by 5. 60.319. And it's a volume, so it's units cubed. Okay, this one we did as well. So again, we have to graph. So we're in the first quadrant only. We have enclosed by the y-axis, so here, and then the graph of cosine. So that is cosine. And then sine starts here and goes up. So it's enclosed by the y-axis and these two. So it's this region right here. And it's going to be revolved about the x-axis. So here's the x-axis to form a solid. And when you're doing these, I highly recommend that you reflect this shape, in this case, over the x-axis. So this is going to go down, and then this will be something like that. And it's important to be able to visualize these. Let's do a cross-sectional shape. So since we're revolving this way, the thickness is going to be dx. So here's the cross-section. And can you visualize what, if I was to take just this cross-sectional shape and I'm rotating it around, I can't really show that on 2 dimensions. Can you visualize what shape you're going to get? I'll try to draw it here with, maybe what color could I try? So this is going to come out to here. This is going to come out to there. This will come around to here. This is going to be kind of around to there. And then there's a center that's, you see how there's a hole in the middle? So what you're getting is you're getting a washer. Like that. That's the shape of that cross-sectional piece, that yellow slice, if you think in 3 dimensions. And so we need to, it's no longer a disc because it's got a hole in the middle. So we're going to set it up slightly differently. So think about finding the volume of this. How would you find the volume of this disc? Well, you would find the area, the big area, minus the little area, right? Times the thickness. So the big area is pi times the big radius squared minus the little circles, the area of the small circle, which is pi times little radius squared. And then you would multiply that by the thickness, which in our case is going to be, because we're going to use an integral, we're going to be summing these. This is going to be dx. And when we sum them all up, that's our integral. So this is the formula we're going to end up using. And this is called the washer method, by the way. In fact, we factor the pi out. So it looks like that from A to B. I could draw these radii in there too a little bit. I'll try to do that. There's the big R, and then the little r is right there. Okay, well, let's set this thing up. So we've got, I'll take the pi out front, the integral. The big radius is from the axis of symmetry, or the axis of rotation, up to the outer curve. So the outer curve is cosine. And we have to square it. And then minus. The little area is from the axis up to the smaller curve, which is sine, but we have to square that. And then dx. And then the limits are in terms of x's, because I'm all in terms of x's, so the x's go from 0 to where they intersect, and sine and cosine are equal at pi over 4. So here's the setup. Now, you can try to think about how to integrate this. If you try use substitution, which we talked about this in class today, if you tried making, well, oh, I gotta have birthday. If you tried making like u equal cosine x, then your du would be, the derivative of that is negative sine of x dx. And the problem is, you have a subtraction sign here, so really what you'd be doing is separating these two integrals anyway, and then if you just separated them, here you would have the u, but you wouldn't have it's not being multiplied to a negative sine of x or even a sine of x. So you would get stuck with the u's and du's, or I mean using u substitution. But, so looking at it, you might not be able to think of a way to integrate this. However, keep in mind that anytime you are trying to integrate trig functions and you don't have an apparent method, you can try identities. And if you look in your identity sheet that I handed out at the beginning of the year, you will find that cosine squared x minus sine squared x happens to equal cosine of 2x. That means I get to replace this whole thing with cosine of 2x. And now it's pretty easy to integrate. So let's see, that's going to be negative, or no, not negative. Sorry, that's not right. Sine. Sine of 2x over 2. There's the pi out there from 0 to pi over 4. And then we've got, I'll just take out the pi over 2 out front. So these are out there. And then we've got sine of 2 pi over 4. That's the same as sine of pi over 2. Minus, and then we're going to have sine of 0. So sine of pi over 2 is 1. 1 minus 0. So you get pi over 2. And it's a volume, so it's units cubed. That was a pretty cool little identity we had, huh? Here's the washer method, so you can pause this and write this down. Keep in mind this note here that you're squaring each of these individually. It's not the whole thing. It's not. You don't want to do the whole thing squared. That's that. Be careful not to make that mistake. We skipped this one just because of time. If you want, you could draw this and try it and see what you get for an answer. Let me tell you the answer in case you do want to try it on your own to get some practice. The answer is 2/3 pi units cubed. And then we did do this one. This was the last one we did in class. We had the derivatives and integrals test today, so that took up a little bit of time. Plus we seem to kind of be in a little bit of slower mode today. Okay, we've got the x-axis, the line y equals x minus 1. And the line y equals negative x plus 3. And they happen to cross, if you count the slopes and stuff, they cross here. This is actually 2, 1, where they cross. So R is the region bounded by the x-axis and these two lines. So it's this little triangular region here. And we are going to be revolving it about the y-axis. So again, I recommend that you reflect this over the y-axis. So this little triangle would reflect to right here. And the goal of that is to try to help you visualize it, because if you can visualize it, it helps you set it up correctly. So what I'm going to do, since this is being revolved around, I'm going to try to draw the little ovals here. So this is going to come around there. Inside there's going to be this little thing. Does that help a little bit? Hopefully it does. So this is kind of comes around there. So it's kind of, Johnny drew this really cool little, he drew it like this, and then what you have is you have these little triangular, so there's kind of a center here. There's kind of this, the tops of these triangles come down. Wow, that's like the best thing I think I've ever drawn this. See these triangles coming up? There, that's actually pretty darn good. There's the shape right there. And we're going to find the volume by slicing it. And how should you slice it? With the dx or dy? Well, you can get a pretty good hint from the fact that you're going across the y-axis in this one. You're going to want to use dy. So here's my slice, dy. You have to slice it all the way across. Okay, can you visualize, if I just take that three-dimensional slice, what figure it is? It's going to be a washer again. And I'm getting a little out of hand here. So that's this little slice kind of exploded here. It's another washer, so it's going to be the washer method again. But the slices are in terms of y. So it's going to be dy. That means the limits are going to be the y's. So the y's start at 0 and they go up here to 1. And then it's a washer, so it's the washer method, which is pi times big R squared minus little r squared, dy in this case. So I've got my pi out front. And then my big R is from here out to here, which on my picture here, I'll come down here, it's from the center, the axis of rotation, out to the outermost curve. The outermost curve, there's another option. The outermost curve is this one right here, this negative x plus 3. However, because it's in terms of y, we need to solve this for x and get it in terms of y. So x will be 3 minus y. That's my big R. I have to square it, subtract, do my little r, which is from the center out to this inner curve, which is this one. Again, I have to solve for x and get y plus 1. So y plus 1 will go here, and it'll be squared. Now it's set up beautifully. Everything is in terms of y. And then what you can do at this point, of course, is FOIL this all out and FOIL that out and subtract and combine and integrate. And I'll just tell you the final answer. You can try that on your own. You should get 4 pi units cubed. And that's as far as we got today.